You've probably heard people call AI a black box, this incredibly powerful but totally mysterious tool that we can't really see inside of. Well, today, we're going to shatter that box. We're pulling back the curtain on artificial intelligence with a revolutionary idea that shows us exactly what's going on inside.
I mean, you hear it all the time, right? Artificial intelligence, especially deep learning, is a black box. It makes these incredible, sometimes world-changing predictions, but how? What is actually happening inside that complicated web of artificial neurons? It's a huge question, one that has stumped even the smartest folks in the field for years.
All right, so before we get to the really mind-blowing part, we first got to get on the same page about the problem everyone's been trying to crack. Let's start with the AI black box.
So here's the deal. You feed an AI some data, that's your input. It spits out an answer, that's the output. But that whole process in the middle, the internal logic, the actual reasoning behind its final choice, that is often a complete mystery, even to the people who built the thing. And you can see why that's a huge problem, right? Especially now that we're starting to trust AI with really critical decisions in medicine, finance, you name it.
Okay, but what if this whole black box idea is just wrong? What if we could flip the entire script on AI? And that brings us to a radical new idea. What if we've been looking at it the wrong way this entire time? Imagine for a second the box isn't black, but it's more like a glass box. Imagine we could actually see inside and follow the logic step by step.
And this, right here, is the bombshell idea from a paper by researcher Çağlar Aytekin. And it is a huge deal. The idea is that you can take any neural network, I don't care how complex it is, and you can perfectly represent it as something we can all wrap our heads around. A simple, logical decision tree.
And listen, the most important word there is exact. This isn't a rough sketch or a kind of sorta model. No, we're talking about a decision tree that is mathematically guaranteed to give you the exact same answer as the neural network for any possible input. It's a perfect one-to-one translation.
So you're probably thinking, how on earth is that even possible, right? How does this tangled, complicated web of neurons turn into a nice, neat, orderly tree? Well, let's break down how you get from a single neuron to a clear, decisive branch.
Well, it's actually kind of beautiful how it works. Think about it. At its very core, what does a single artificial neuron do? It gets some information and it makes a simple binary choice. It either fires or it doesn't. That's it. Think of that as a simple yes or no question. And that one question, that becomes the very first branch in our tree. So as you move through all the layers of the network, you're just following a path of these yes-no decisions. It's brilliant, really. Each complete path, from the very beginning to the final answer, is just one single clear rule in the decision tree.
So let's just put it side by side. A single neuron activating in the network, that's the exact same as the tree asking a simple yes or no question. A whole layer of those neurons, that's just a new level of branches on the tree. And a specific path the network takes to come to a conclusion, well, that's just a straightforward set of rules. Suddenly it's not so mystical anymore, is it? And get this isn't just some trick that works on simple toy AIs. Nope. The crucial point here is that this idea applies across the board, from basic feed-forward networks to the really complex convolutional networks that we use for image recognition, even to recurrent neural networks that handle things like language. Every single one of them can be unfolded into this logical structure of branching decisions.
Okay, so we know it's possible. It's cool. But so what? Why is this more than just a neat party trick for researchers? Let's dig into how this discovery basically changes everything we thought we knew about AI.
I mean, this is the real question, isn't it? It's a fascinating bit of math, for sure, but what's the real-world impact here? For us, for the tech we use every day, for the future we're trying to build?
Oh, the benefits here are huge. First off, transparency. Boom. We can literally see the logic laid out right in front of us. Then there's traceability. We can follow the exact step-by-step path the AI took to get its answer. And those two things together lead to true interpretability. We can finally answer the why question with total certainty. And hey, as a nice little bonus, sometimes running the decision tree version can actually be faster and more efficient.
All right, let's pull all these threads together. Let's take one last look at this new way of thinking about AI, a way that takes us far, far beyond that old, outdated black box idea.
So this is the new picture I want you to have in your head. We need to stop thinking of AI as some unknowable dark box. A much, much better metaphor is a massive forest. A forest of decisions. Yeah, it's huge and it's super complex, but every single path through that forest is clear, logical, and something we can actually follow.
And this just nails it. For way too long, we've mistaken complexity for magic. But the reality is, neural networks are just highly structured, layered systems built on simple decisions. Are they incredibly complicated? Absolutely. But are they fundamentally beyond our understanding? Not at all.
And that really leaves us with one last huge question. For what feels like the first time, we might actually have a kind of Rosetta Stone, a way to translate the language of artificial intelligence. So the question for our future isn't if we can understand AI anymore, it's when we finally do, what incredible and maybe even surprising things will it tell us about our world, and maybe even about ourselves. Thanks for joining me.